Okay, so we already know now what is the difference between numerical control and computer numerical control. Because this technology or the technology of numerical control is rapidly growing or improving with time. So after the after they start to use the computer numerical control, they start to improve. Then there is a new technology which they call it direct numerical control, or DNC. So the direct numerical control here, they start to work with the networking. Okay, so instead of controlling one machine, they start to find multiple machines to be controlled at the same time from the same host or from one computer. So they have multiple CNC machines. Maybe these CNC machines are used for one operation or to perform one task, or maybe this CNC machine can perform multiple tasks. But at the end, we have multiple CNC machines, and they connect this all CNC machine to be controlled by using one DNC main host computer. So one computer to control, for example, 3, 4, 5 CNC machine. So actually, this control also will be performed in real time. So instead, there is a local control for the CNC here, but also we have network control for the whole CNC machines. So this actually depends on the 1960 technology. And when we said 1960 technology, that means they start to use this type of controlling over the NC machine in the beginning. Then the CNC machines, which is the more, the CNC machine, but the old version or the conventional CNC machine that they start, not the CNC machine, the most recent one. Because for the current CNC machine, they start to use another type of control for networking. We are going to see. Okay, so there is two-way of communication. When we say two-way of communication, that means from the server to the from the host here or server to the machine control unit or MCU, then also from MCU again to the server. So it's two-way direction. So several machines here can be linked together to the main computer, and programs can be written from the main control computer and sent to the local CNC machine, and the data also can be go on the other side for the upload, like in download and upload directions. So this we call it direct numerical control. This is how the DNC server looks like. So we have the server here, and you have the CNC machine here. This is another CNC machine, another CNC machine. All they connect in two directions, upload and download with the host computer or the main computer server. So in this case, you are going to, for example, if you have several machines, they perform the same task, and you want this machine to produce the same product at the same time. So you are going to write only one program, then this program will send to all machines. So the machine will run and produce the same product. That means to duplicate or to repeat the production of similar product, so you can send this at the same time to produce multiple machines. If you have different machine also, for example, you send this program to the first machine to perform that, then the other program to the other machine, and so on. So you have multiple CNC machines which connected to the one server or one computer. These systems are more improved to perform or to form the distributed numerical control. So distributed numerical control that we mentioned before in the first class. When we have distributed, that means or distributive or distributed numerical control here, we have a network that consists from the main host, and you have this main host. Also, there is another. It looks like you have multiple direct numerical control. This is direct numerical control. This is direct numerical control. You connect together to perform one distributed numerical control. Okay, so here we have computer, we have several CNC machine. It looks like one direct numerical control. Here you have computer with CNC machine. It's like one direct control. So all connected in a network to one distributed main host computer here to perform the control over all the existing NC or CNC machine. Here it used the present technology. That means the CNC machine here are more modern or more or advanced with advanced technology. They support new type of software, new type of communication technology, and so on. Also, it performs two-way communication from the server here. I mean, from the DNC computer here to the main to the distributed computer, and also on the other side to the DNC computer. So several DNC systems can also be networked to form a large distributed system. So the DNC here, the first DNC is referred to the direct numerical control. Okay, so you have direct numerical control, they come for distributed numerical control. Why we need such system? Actually, because when you have only CNC, that means you are talking about one machine. So this machine, it has a computer, it's okay. It's okay for small workshop. But if you want to make it for a factory, so in the factory you have several CNC machines. So it's not efficient to control each CNC machine locally from its computer. So it's better to connect all these CNC machines in the factory into one network and then perform supervisory, or I mean, like you control from one control server located in the control room. It may be far away from the field or the local machines here. Okay. So as you can see here, so this is a more or the diagram, also block diagram to show the distributed numerical control. So you have bulk memory NC program here. When we say bulk, because you are talking about several direct numerical control system, which consists of several or with a number of CNC machines. So you have the general computer here. You have telecommunication bus or lines, and this bus or line is connected with the local MCU or machine control unit, and in two directions, upload and download. So the connection to MCU is behind the tape reader, they call it BTR, or behind the tape reader. So instead of you have the, behind the tape reader, that means it will allow the computer or the general computer to send the program into the MCU of the CNC machine, and also to upload the data or the information from the MCU of the CNC machine again to the general computer line. Usually the DNC or the distributed DNC systems can be exist in two types of networking. Since we are talking about networks, so there is a two main types here. One, we call it switching network. Switching network, that you mean that means you have a data. If you talk about the network, when we talk about networking, we are talking about the like router, switch, and so on. So we have data switching here box, and this data switching box is connected to multiple CNC machine. This one CNC consists from machine control unit and machine tooling, machine control unit and machine tools. So this is CNC, for example, this is another CNC, this another CNC, and so on, all connected to the data switching. It's like a switch for data. So it can, this switch of data, it will organize or arrange how the data will go up to the DNC computer or go down from the DNC to the different CNC machine. So for example, this computer will send command to this machine. So this switch will perform or will route the data come from this computer, go directly to this machine. It will not send to the wrong machine. So this we call it data switching box. Usually it depends on addressing and so on. Like we use like IP address, for example, in the normal network. So when I call this IP of this network or of this machine or MAC address and so on, so it will send the data to this CNC machine. The connection usually using RS232C here. This is the type of connection. And the cons of this type of networking is limited number of machines can be connected. So it depends on the capacity of the data switching box. Maybe some data switching box support for 4 CNC machines, some data switching box support 8 CNC machines, and so on. So it has a limited number, it's not open. So you are controlled by the number of ports available for connecting these machines. So each switch, it should have a defined number of ports. So based on the number of ports, you can connect how many machines you want. The second is local area network, and this is the normal LAN network that we use in our networking when we connect computers to each other. So you have a bus here, and from the bus or the common bus of the network, each satellite computer can connect. I mean, each DNC here or direct numerical control can be connected to the bus. Whatever is the number of bus is not limited. It's not. We do not have limitation in terms of the number of connected DNC to the DNC computer. So for each time, this DNC computer will send the data to the local computer or satellite computer here, and this will perform the control over the CNC under its control, and that one will perform. It's like hierarchy. So it's you have one main and you have more down to control several. So if one of these controller got problem, others controller will stay running, and also the communication between the server to the local host computer is still operating. So this is like an overview about the three types of numerical control, which is numerical control, the conventional numerical control, and its component is the part program, controller or MCU, then machine tooling. So this is MCU here. This is the machine tooling. Here, the second is CNC, consists from part program, computer. This represents MCU in this case, and it has machine tooling. The third type, which is the direct numerical control, which is consists from the host, the distributed numerical control, which is consists from the host computer, and you have the local computers here or the satellite computer, and then you have the machine tooling under them. So this is how the system of or how the numerical control system become more complicated, starting from a simple machine with a simple controller with the keypad only for and a tape reader, then go for computer, and then you have several computer and represent a network with the server and host computer. Okay. No more time to go for 1 week for chapter 1. Are you there or not?
Yes, yes sir.
Yes, sir.
One answer, okay. Okay. So
Yes,
now
sir.
enough. One answer only. Okay. The first one, first come, first serve. Okay. Application of NC here. There, we already mentioned before for several application of numerical control. Now we are going to highlight again, the list of numerical control application. Then later on, we are going to state the CNC application, because there is some applications which can be which use CNC but is not use NC. Some applications specific or more specific for CNC machining, not for NC machining. Okay, so the common all application of NC are also existing in the CNC. All NC application are exist in the CNC also, but CNC has more application than NC. So for the NC here application, machine tool application, that means applications which depends on machine or needs for rotation and so on. So we have milling, drilling, turning, boring, grinding, and so on. Machine centers which combine of one or two, of more than one machine. So you can have, for example, turning centers, mill turn centers. That means combine of two process or two type of machines on the same machine. So one machine can perform 2 tasks, for example, or one machine can perform 3 tasks or 4 tasks in sequence. Okay. Then punch process like thermal cutting machines and so on. Okay, so this is the part which is related to the machine application. There is also non-machine applications, which is not depends on the machining here. So like punch process of hole punching, tube bending, thermal cutting, wire electrical discharge machine, welding machine. Some of these machines actually already mentioned in the video that we watched in the beginning of this lecture. So each machine actually, or each type of this machine, it has its own structure, own tools, even it's common, or they have the common in the part of I mean the machine control unit, but the tooling part, which is the tooling part or the machining part, is different from one application to other application. As you can see here, this is like representation for the turning process, milling process, drilling process, and grinding process, and it shows you some of the tool that will be used for such to perform such type of machining. Later on, we are going to talk about some of these machines in details in the upcoming chapters, and we are going to learn how to write the program for to perform some of commands or operations for these machines. You can find actually in YouTube a lot of videos about each process. You can see how the turning is operate, how the milling is operate, how the drilling, how the grinding, and so on. Different type of NC operation. You can find it in either in the 3D animation or in real machines. The NC application characteristic here, where NC is most appropriate. So I mean where we prefer to use NC application or NC machines in our in the manufacturing part, on manufacturing field. The first is the batch production, and we said batch production. We mentioned for batch process last time. We said there is some process which work in batch. So the first batch, for example, we said there is a mixing, there is a heating, and so on. So there is a batch. So for example, each batch can be carried out by using one NC machine. Then repeat orders. So you need to produce the same product for 100 times, 1,000 times, and so on. So you need to repeat the same orders for the machine. So you are going to use this NC machine. Complex part geometries. That means the direction. I mean, you need to define more than three axes. You have 4 axes. You have 5 axes of operation, and so on. You need to. It's not the normal or the linear dimension. You need to define. So you need to use NC machine here. Match metal needs to remove from the starting work parts. You need to remove some part of the machine to make it smoother, and so on. Mini separate machining operation on the part. Part is expensive, so you are worried about if you do it manually, it will be broken or it will be damaged. So it's better to use the machine. So this is where it's preferred to use such NC machining. Other application of NC, in addition to the existing NC application that we mentioned here, which is depend on machine or non-machine, also there is other application like electrical wire warp machines, component insertion machine, drafting machines, coordinate measuring machines, type laying machines, eliminating machine, rapid prototyping, and additive manufacturing, water jet cutting. All these applications actually, all these applications refer to the NC applications, and also at the same time to the CNC applications. So these machines or this application can be used for, I mean, are existing in the conventional numerical control machine and also exist in the computer numerical control machines. But as we said, there is some like we have add-on features for CNC, we have add-on application for CNC also. These are the industries involved with the NC or with numerical control. So when you graduate later on, you will go to work with aerospace, with machinery, electrical fabrication, automotive instrumentation. I mean, this course is involved, or this topic of the control, numerical control, is involved in all these field of industry. Okay. This type of CNC machine, and here was just some figures we are going to go for to know more, because since CNC is the most current version of numerical control, that means nowadays it's difficult to find NC machine. Even is still there, but it's not. I mean, people not used to use it anymore because it's not that efficient comparing with the CNC. So, but for those who has limited budget, they still keep their own NC machine since maybe 1970s, 1960s, and so on. But the most of the existing machines are now computer numerical control machines. So this is the application of CNC. Some of this machine we already mentioned in the NC, and some of machine are not existing with the NC machine and are special application in CNC machines. This is the CNC turning machine. I mean, if you see, I mean, you try to find it on the YouTube about this one, you can see how this CNC machine is operated for turning the materials. This one is for milling. As you can see here, the computer is placed in this area. And here is the table or workspace for the machine. This CNC laser cutting is used to cut the material or the metals by using laser. Plasma cutting, press, rapid prototyping. To produce the prototype, I mean, you already have the product, you make a design in 3D, you just go for send it to this machine to get the prototype of your product. This sample of products that can be produced by using CNC machine, as you can see here, starting from engine block, either engine block for engines or engine block for maybe for automobile, engine block for aerospace, and so on. I mean, it's just engine for any type of applications. CNC model making here to make a model. Rapid prototyping, you can use some materials to produce such prototype. Also, you have some of different products here for nuts, bolt, and so on. Also for aircraft turbine, machined by 5X CNC milling machines, as you can see here, also even for aircraft. So all the field of manufacturing currently use such CNC machine. Maybe by 2025, this field of study of the CNC machining is become one of the most important field in the world, especially now with the I mean, with the focus more on robotics, and I mean, the factory will be running automatically and so on. So they are going to use a lot of such machines in the industry. I mean, to reduce the labor cost, to reduce the number of operations and so on. I think that's all for today.